Hey guys, this is the High School Scientist and this is a follow-up to my previous video on dot product of two vectors. In this video, I'll be explaining what cross product of two vectors actually means. So let's start by taking two vectors, say v and w. We can represent them in Cartesian coordinates, but that wouldn't be necessary for now. So when we have two position vectors, we can form an area covered by those two vectors when they are in the limits of each other. Okay, like you can move a copy of the vector v all the way to the end of vector w, and shifting a copy of vector w all the way to the end of vector v will give us an area covered by these two vectors, and this area is the cross product of v and w. Well, almost, because remember, vector product should also have a direction. So we also have to consider the position or the orientation of the parallelogram. Like in the case of dot product, orientation didn't matter because over there v.w and w.v were the same thing. But in cross product it's different because v cross w is not equal to w cross v, instead it's equal to negative of w cross v. So yes, order matters in cross product. But why? Well, because cross product is multiplying two vectors to get a third vector. So now the magnitude of the third vector will be the area of this parallelogram, but the direction of this third vector would depend upon the orientation of w and v vectors. So if we were to find the cross product of v cross w in this orientation, then the resultant vector would be poking out of the screen towards you. But if these vectors were flipped, then this resultant vector will be facing towards the back of your screen. So the orientation of the resultant vector depends on the right hand screw rule. But why does it have to obey this rule? Okay, as of now, I have been telling you what this rule is and the way it works. But I think it's also important for you to know why it works. Well, you can think of this as a way of naming things. Like a coin has two sides and we call them heads and tails. So just like that, the area formed by these two vectors also have two sides. And since we live in a three-dimensional world, we have to know which side is the top side and which is the bottom. So basically that's why we use the hand rule. By the way, it's really simple. You point your index finger in the direction of the first vector and point your middle finger in the direction of the second vector. Now whichever direction the thumb is pointing towards is going to be the positive side and the side opposite to it will be the negative side. Okay, so now we know where the resultant vector is going to be. But we also have to represent this in a pure mathematical equation. So it's simple enough for us to make good use of it. And here's where math just gets amazing, because it gives us patterns to play with. So if you notice that the area of this parallelogram is maximum when the vectors are perpendicular to each other, and minimum when the vectors are parallel or lie on top of each other. And this is exactly like the values of sine. Whenever theta or the angle between the two vectors is 90 degrees, the value of sine theta is maximum, basically 1. And if the angle or theta is 0 degrees, then the value of sine theta is also 0. And so that's why the cross product of two vectors is directly dependent on the values of sine of the angle between them. Hence, we can state the formula of cross product of two vectors as magnitude of A multiplied with the magnitude of B, and finally multiplied by the sine of the angle between them. So this was my video on cross product of two vectors. I hope you learned something, and if you did, then just spread the word, let your friends and classmates know about this channel. This is the High School Scientist signing off.